Hi, and welcome to Easy CQRS with DAB and SQL. My name is Jerry Nixon. I'm a product manager on the SQL Developer Experiences team. I'm excited to talk about CQRS. You may already know, it stands for Command Query Responsibility Segregation. It's pretty big. The acronym saves us from an incredible title of Easy Command Query Responsibility Segregation with DataAPIBuilder and Azure SQL Database. So we'll keep it nice and simple. The truth of the matter is, this pattern is actually very simple, as powerful as it is in the way it enables you to be able to handle bursts of workloads or really large concurrency. It is very straightforward to implement. Why are you thinking about it right now? Well, maybe you're thinking that there is something coming. Maybe it's seasonality. Something is coming for the holiday or some other reason, and you expect a really large burst of users or operations against your database, and you want to plan for that. Maybe you're about to merge or acquire another company, maybe whatever. Okay, that's one thing. Maybe you just work for a company that has a lot of employees. Maybe you work for a call center that has a lot of people manning the calls. Maybe you work for a company that has so many simultaneous users that it really is starting to impact the read or write performance of your application, and you want to find a way to solve it, and this is the way we can solve it together. So in this session, we'll be going through making that database so that we can think about how to separate that out into a replica and implement CQRS. We'll also talk more specifically about data APIs and implementing CRUD operations automatically using DataAPIBuilder. Before we get started, however, I want to just point out that there is a brand new learning path on the Microsoft Learning site. Now, a learning path brings together all of the information you need for a specific family of topics. Now, for this, it's Microsoft Azure SQL Database. You maybe have already noticed a lot of innovation in the last little while has really been pouring into SQL, and you may feel like it's getting away from you. Well, this is the way to be able to wrap your head around it and understand not only what they do, but also how to use these to help you not only in your own developer experience, but also your company and the solutions you're building. Then we also have an applied skill, and this is validated and confirmed. It's a credential you can get from Microsoft that is called the Developer Data-Driven Applications, and you can find it at akms/sql/dev/path. It's completely free and a great way for you to be able to both establish the skills, but also show off your skills in a credentialed way. Let's begin at the beginning. So to start with, we all build an app. The app that we have is simple and it doesn't have much going on, and the first thing we introduce to it is a database. The purpose of a database is not just to store the data, but we extract it outside of our application so that we can share it with multiple apps and we can have many users simultaneously. Now, at this point, we're talking to the database directly. Maybe we're using Entity Framework or something along that lines. And then we start thinking, business rules, business logic, or perhaps we have other reasons as well, corporate policy or something along those lines that say, no, don't talk to the database directly. Instead, introduce that middle tier of a data API. A data API is a little bit different than a web API. They both are web APIs, but a data API typically is CRUD operations, CRUD, that's create, read, update, and delete. It's a layer on top of your database to make it so that instead of interacting with the database, you're interacting with simple endpoints. Those could be REST endpoints or GraphQL endpoints. It's sort of up to you, but it makes it so your application is talking to your database over HTTP using JSON, and you're no longer really writing T-SQL or anything along those lines. You might also have an E, by the way, CRUD, in case you're executing stored procedures, but that's just a thing. Okay, Microsoft Data API Builder is a free and open source tool that you can use to automatically create a data API over your database. That's a database that's SQL Server, Azure SQL, Cosmos DB, Postgres, MySQL. It's up to you, but it's not code gen. That's not what it is. It's just an engine, and you provide to it a JSON document that describes your database, a JSON document that says, these are the tables, these are the views, these are the store procedures that I want to expose through my data API in this way. And you can granularly control both access and control. You can make it so that you can alias things and you can expose them as REST endpoints, graph endpoints, or both REST and GraphQL endpoints. Data API Builder is one of the cooler things you'll ever implement in your solution. And let me just say this. If you are building CRUD data API projects from scratch today, you're probably copying them from previous projects, and you're introducing a lot of code, a lot of repositories, a lot of unit tests, and a lot of extra time in your CI/CD pipeline that you really should be able to avoid. So I encourage you to look at Data API Builder. It's a way to make it so that you just don't have to write the repetitive CRUD code over and over again. Okay, regardless of if you're using Data API Builder or not, one of the first steps that we'll think about for CQRS is to take it so that our data API is split from read operations and write operations. So in this case, we don't really need to write separate services. We just need to host them in separate places and then dedicate the operations in each just to the write and just to the read. Now, to be 100% clear, write operations in the right service are the correct thing to do. Read operations in the right service can also be correct. There are times when you write something and you need to immediately read. That's fine. Read operations, however, tend to be very isolated, making it so that the service that is dedicated to read never actually writes. It's very rare to see any write operation from a read service. Now, it might be that both of these are the same code base and you're just very careful which one you call, or it might be that you've separated and created two code bases, one for your write service, one for your read service. The way that the database works now, however, we tend to refer to more as HTAP. HTAP is the hybrid transactional analytical processing way of it allows a database to enable both transactional, that's OLTP, and analytical, that's OLAP workloads to run on the same system. Now, if we were just to simplify that, I would say transactional meaning write operations and analytical meaning read operations. So to run at the same time, all databases can do that. So what's special about it? We're really talking about high concurrency and really high volume, right? And so HTAP says, okay, you want to do some massive writes, do it. You want to do some massive reads, do it. You want to do them both at the same time, do it. And that is the power of a really nice database. However, there will eventually come a time where you push a database to its limits and you can't feasibly make it so that it's just a larger database. It can be very expensive to make it so your database is really large, but it can also be very unnecessary because we can use the next step in the CQRS pattern to make it so that not only our services are now separated so that the write and read are in two different places, we also make it so our database is also separated. Most explicitly here, we create a replica that is intended for read only. So this is important. The primary database, the one on the top, continues to be the main thing that's written to, and it synchronizes down to the replica. Read operations then read from the replica, making it so that really expensive and high compute read operations hitting the replica make no impact to whether or not you can write to the primary database. That's what's beautiful about it. There are different techniques, and we're going to be talking about specifically hyperscale. So hyperscale is the SKU that basically everybody should be using with Azure SQL today. Hyperscale has two different types of replicas, though, and I think it makes sense for us to just walk through and talk about what the differences are. The first one is a failover replica. Now, any database can have up to 4 of these, and here's what's awesome about them. A failover replica becomes the primary replica at any point that the primary has some sort of a problem. It's automatic and it's really fast. So that's the benefit. I can have up to 4 of those. So that if I was really serious about high availability, I could make it so that I have several replicas sitting there and they're nice and warm and they're ongoing. So one of the things you might want in your database is to make it serverless so that it pauses, right? And goes to sleep sort of after use has slowed down and stopped for a period of time. Now, that's not the way that a failover replica works. A failover replica is always nice and warm. It's primed, and it is ready to take over at any time. So the upside is they're awesome, and they do 2 things. I can point to them as read-only replicas, but I can also use them as failover replicas. The downside, of course, is that they need to match the configuration of the primary database. So if you have a really large primary database, you're going to have a really large failover replica. The second type of replica that we can have in hyperscale is a read-only replica, sometimes called a named replica. A named replica is really nice because a named replica can be any configuration, any compute configuration. It can be really, really large to make it so that your reads are super fast. It can be really, really small. It can be serverless if you want to, so that it goes to sleep, whatever you want, and you can have 30 of them. The way hyperscale works and sets off its pages makes it so that the replica is up to date in an incredible way. These are just considerations, right? Which one is right for you? Well, do you need high availability? Well, if you need high availability, then obviously you're going to need a failover replica. If high availability is not the target, or you're very budget conscious, then you're going to back down to a named replica using a read-only replica. No problem. You can have up to 30 of those and go to town. And if you change your mind, and you can always switch back and forth. All right, so those are the 2 types of replicas. Let me just talk about how we use them. Inside your application, the read service still talks to the primary database, and it passes in the query string a new name value pair. The application intent equals read only. Saying application intent equals read only in the connection string says to the primary database that you have no intent of writing to the data, and so it automatically redirects you down to one of the read only replicas. In this case, the app intent redirects you to one of the failover replicas. Pretty cool. Now, the failover replica is a little bit different, right? The failover replica says, if anything fails in the primary, I want to automatically go to one of the high availability replicas. That's automatic for you. You don't have to program to that. It just happens. This is the way it's designed. And it is beautiful if one of your goals is to have no downtime at all. All right. I think it makes sense for us now to go into a demo and just talk about implementing CQRS in our code by building out our database, building our environment, and building out our application. And welcome to the Azure portal. All right, we're looking at a resource group I have here called dotnetconf. Inside a resource group, I can add all kinds of Azure services. I've already created a SQL Server. Now in Azure, SQL Server is not the database. It's just a logical container for the database. So let me go into the server, and it gives me the option at the top to create a new database. I'll click on that. And the first thing I'll notice is it offers to give it to me for free. That's because every Azure subscription now qualifies for a free SQL Server. That's a SQL Server that's free to your subscription for the lifetime of your subscription. It doesn't expire in a few weeks or months, doesn't even expire in a few years. It's for the lifetime of your subscription. That's as great for creating a POC or just poking around and learning SQL. All right, so let me scroll down and notice a couple of things. So the first is I'll give it a name. So my database name is going to be .NET Conf database. All right, so that's my database. The database is already in the server that I created, and I'm not going to make it elastic pool. That's where they share resources across multiple databases. I'm not going to make this a production. I'll make it a development, which automatically switches it to be serverless. Now, I want to make some changes here because what it has selected for me is general purpose serverless. I want to make sure that I'm doing this with hyperscale. So configure database allows me to choose if it's hyperscale or not. So here's general purpose. I'll drop this down and I'll say I want hyperscale. Remember, hyperscale is the SKU that everybody should be using now. And so it's really powerful for us. I'll go ahead and switch this to provisioned because provisioned allows us to create hyperscale replicas. I'll just select serverless and point out that it's gone away. That's because hyperscale replicas are always on, right? So if you are looking for high availability, then you want provisioned. That gives you the option for high availability replicas. All right, so let me scroll on down here and show you a couple of really great things. So the first is the number of cores. This is the virtual CPU that you'll be able to use to determine the compute size of your database. 2 is fine. And then the number of replicas right here. So by default, there are 0. I could scale this up to 1, 2, 3, and 4. I have 4 backup replicas. These will automatically become the primary if anything happens, but it also allows me to have multiple read-only databases if there's no high availability issue at hand. So let me back this down to just 1. And let me go ahead and say apply and all the way down and say review and create. The only thing left to do is just click create. All right, the deployment is complete. Let me jump to the database and click on connection strings because I'm going to need my connection string to interact with it from code. And welcome to Visual Studio. I have a solution here. It's completely empty. It's called dotnetconf. And the first thing I want to do is to create a SQL database project. The SQL database project allows me to, there we go, and yes, allows me to interact with my database and create objects and keep all of that in source control. Very similar to EF migrations, only instead of being code first, it's database first. The first thing I'll do, though, is add a new object here. I'm going to add a view. That view is going to be called info. I'm going to ask my database whether or not it is allowed to read or write. And the way I'm going to do that is by asking a database extended property and query its updatability. That will return back either read-write or write-only. I'm going to right-click and say publish and publish this database back up to Azure. Once I have my server in there and my database is right, I'll test my connection. It'll tell me that I haven't set up my IP address. And so to fix that, I'm going to add my client IP address automatically here. That's because the user that I am has permission to do that. Otherwise, I need to go back to the portal and do it from there. Once finished, I can test the connection again, and this time it'll tell me everything is good. All right, so all I need to do is click OK here and click Publish. This will take everything that has changed in my database project and synchronize it with Azure SQL Database. Great. Once that's successful, we can go in and add a console application so we can interact with our database. I'll right-click, say Add New Project, and select the console application. Calling our SQL database is going to be pretty straightforward. I'm not going to do anything fancy, just create a method that calls out to that and returns the scalar result. Great, this does exactly what I want to do, except for it's using the incorrect connection string. I'll paste in the one from the portal and make sure that we're using our variable. Let me go ahead and call it get scalar value async and write it out to the window. All right, I'll go ahead and add a console.readline just in case the terminal tries to close on me. The last thing I want to do is make sure that we have a SQL client. I'll go in and say, install the Microsoft Data SQL Client. Just a reminder that Microsoft Data SQL Client is the preferred package going forward. I'll add my using. Let's go ahead and select server info from info. That will call our method, that will call our view for us. I'll go ahead and hit F5. That'll open up the terminal, call out to the database, and it tells us that it's read-write. Now, the reason that it's read-write is it's going to the primary database. We have a secondary replica. Now, that replica is a failover replica, but it's also a read-only replica. In order to access it, all we need to do is change our connection string to include application intent. Intent equals read only. This extra name value pair in our connection string communicates to SQL that it doesn't want to use the primary database. It wants to use the read-only replicas. So now I'm going to go ahead and hit F5 again. It'll call out to the database with the new connection string. And look, the result coming back is telling us that it's read-only. That means that the primary database received the connection request and passed it off to the replica. This means that every operation from this point forward no longer hits against the primary database, but instead hits against the read-only replica, never impacting our ability to write or the performance of our write operations against the primary. Okay, we're starting to enable CQRS. We've already done that on the database side. We've separated the read and write operations so that we have a primary database and we have this secondary replica that is operating both as a high availability replica, but also a read-only replica, which we get to by adding application intent equals read-only inside our connection string. What we haven't done yet is separate our services. In fact, we don't even have a service yet. Let's start by using DataAPIBuilder. We're back in Visual Studio. I'm going to close our application. I'm going to right-click, and I'm going to open the command line so we can interact with the CLI. I'll start by creating a folder called API. Inside the API folder, we can do everything we want to because I have the DAB driver installed. The way I installed it, because it's a cross-platform .NET tool, I just say .NET tool install Microsoft.DataAPIBuilder, and then I'll make it global with a -G. Now, I already have it installed, so I don't need to run that. But instead, I want to initialize the configuration file that we'll use to build out our endpoint. I'll do that by saying dab init. First, I'll say that this is a SQL server that we're connecting to. Database type is MS-SQL. Remember, it could have been Postgres, could have been MySQL, could have been Cosmos DB. The next thing I'll do is set post mode to development so that we can use things like Swagger and Banana Cake Pop whenever we're trying to debug or use our endpoints while we're testing. And finally, the connection string, which we still have in our clipboard, but you'll notice that it's incompatible because we use these double quotes around Active Directory default. I'll go ahead and change that to be single quotes so that it's nice and compatible. I'll hit enter and it will automatically create the file for us. If I look inside this folder, I only have a single file. It's dabconfig.json. It might be easier to use Visual Studio Code to interact with the file since it's just a JSON file. The file itself has all of the connection information up to the database. We'll ignore that for now and just know that it works. It also has runtime settings that allow me to turn on and turn off GraphQL and turn on and turn off our REST endpoints. Both are on by default. We also don't have any security configured, but that's what I want. And then finally, I'll just show you that we don't have any entities. The entities are the tables, views, or stored procedures that we're going to be exposing through our DataAPIBuilder. In this case, it's going to be a view. Now that you see where it's going to go, let me use the CLI again to add it to the configuration file. Back in the terminal, the command that we want to use goes against the DAB driver using the add subcommand. The next thing is info. Remember, that's the name of our view. So that's the alias that I want to give it, both in GraphQL and in our endpoint. The next is to indicate where the source is. So I could have said DBO info, but this is just the name of the view inside the database. Because the alias and the name of the source itself can be different, it allows me to configure it so that names that might clash with each other can be aliased. I also specify that the type here is a view, VIE, and the W is over here. And then finally saying that the key fields are that server info column. That's because a view doesn't specify a primary key and DataAPIBuilder requires one. So I'm specifying that server info is going to be it. Now, I know that it's not really a primary key. I know it's just a single scalar value, but it operates like one, no problem. We can't set up anything without permissions, so this is me saying that Anonymous can do all of the CRUD operations against this view. I could have made it so, for example, Anonymous can only read. I'll go ahead and do that. When I say go, it modifies the configuration file, and when we jump back into Visual Studio Code, we can see that the entities is no longer empty. Now we have the aliased info, all the source information matching what we had put into the command line. And then down here, some of the defaults that we get where we can see that GraphQL is enabled, REST is enabled, and all of the permissions are set up for read-only for anonymous. That's fine. We don't need to do anything different than that. We can take all those defaults. Going back to the CLI, if I say dab start, that's all I need to do to read that, connect to the database, read the metadata from the database, compare against the configuration file, and then invoke the endpoint so that I can interact with it. I'll go ahead and click on it here so that I can jump. And the root tells me that the status is healthy, as well as I'm running version 1.2. All right, that's terrific. Now let's go in and experiment. So I should be able to say /API/info and call directly against the endpoint. It goes ahead and creates the JSON payload and presents it back to me. Read-write is the value we would expect. That's because I'm not adding application intent equals read-only to my connection string. Let's try creating a read-only endpoint that goes against the secondary database only. Now, what we've done so far is we separated the database with a read-only replica. That's terrific. But next, what we want to do is basically make it so that our read and write services are separated as well. Now, for the sake of this demo, I'm actually going to do it on one machine rather than multiple machines. That's really easy with DataAPIBuilder because I can set up two, not just one, but I can set up multiple configuration files, each with a unique connection string. Let me show you how to do that. I'm going to go ahead and stop this by hitting Control-C in my terminal and then jump over to Visual Studio Code. Visual Studio Code still has the configuration file that I need, and it pulls against, let's go up to the entity named info. All right, let me go to the file here, just do a quick copy paste so that we have exactly the same configuration file. Let me go in and change it, not to be called copy, but instead to be called read-only. Nice. Okay, what needs to change in order for this to point to the read-only replica? Only the name value pair of application intent inside the connection string. So application intent equals read-only. Application. Beautiful. All right, so once you have application intent spelled correctly and in your connection string, you're able to run this and it will point then to the second database instead of the first, right? It'll point then to the read-only replica. And if you have multiple read-only replicas, it will round robin across those as you're calling into them, right? So it's very smart. Now, the problem is I want both configuration files to load at the same time. No problem. Let me jump back to the initial dab config here and add one more configuration setting called data source files. So this allows me to make the first configuration file the primary and then point to many other secondary files. All of those then will be merged together to become one endpoint. However, each of those entities will obey their own connection string. So let me go ahead and say it's dab config dash read-only .json. All right, I will put a comma at the end here because JSON requires that. But more importantly is they both have an entity named info. The problem is when these get merged together, two entities with the same name are going to cause a problem. So let me change this to be read-write so that it doesn't conflict. And just to keep them all named nicely, I'll go down to the read-only version of info and we'll call this read-only, O-M-O-Y. All right. Now that I've made these so that the names don't clash, I'll also make it so that the names inside GraphQL don't clash either. So I'll make this read-only and I'll also make this infos read-only. These are automatically pluralized using Humanizer, and so you can come in and make sense of these the way you want. Let's make the read and write the same way. I'll go and just make it so read, write, and down here I'll say infos read, write. The reason this matters is using it against REST, this wouldn't play a role. All we do is go against the endpoint. The endpoint will have read, write. However, when you use GraphQL, it uses a schema, and that schema then generates unique types, and those types can't clash. And so inside the type singular and plural name, those are where they can't clash. Let's go back to the terminal and let's write it. Let's run dab again. The easiest way for us to do that is to use GraphQL. And what we do there is, like we would use Swagger for REST, GraphQL opens up Banana Cake Pop so that we can interact with our GraphQL endpoint. All right, let me create a brand new document here and start by showing, actually, this little green dot shows that we've received the schema and everything is good. If I click on the schema tab, I can see that we have info's read-only object right here and the info's read-write object right here. Both of them are showing up the way that we'd expect. I can go back to my operation and let's build a query so that we can see what would happen. So I'll start by building a query. I'll just call that A. And you can see I have multiple options here. One is to get by the PK. We'll skip those for now since we know that we're not really doing that. And I'll start by going against my read-write. The read-write operation then will return, and the items is columns, and I'll just ask for server info. When I run that, so you can see the query here, right? So I'm going to info's read-write, going to get my items or columns called server info. I'll go ahead and run that. And here we go. Server info is returned to me as read-write, just like I would expect. Now I can go in and I can do the same thing with read-only. And I can select its server info and run that. And when it does, it brings back read-only. That's because even though I have a single instance of DataAPIBuilder, I have two different config files, each with unique discrete connection strings. However, because this is GraphQL, I can actually run both of these at the same time. And when I run that, they'll still obey the connection strings. So you can see info's read only returns read only as server info, and info's read write returns read write as its server info, exactly what we would expect. Right? It's a neat way to be able to run multiple queries against different connection strings all in the same payload. So this shows us that now we have implemented a version of CQRS that allows us to point not only to different services, but also point to different databases. And this is what we built. Now imagine your application receives a ton of concurrent calls, a ton of things that make the database say, slow down. All of your write operations are go, go, go. And meanwhile, you've also got read operations that are intense. They are looking for things, searching, they are merging and joining tables, doing all kinds of things inside their query. And it is also causing the database to slow down. Now what you've done is you've separated the database so that all those write operations can be isolated. All the read operations can also be isolated. But what you've also done now to the service is you've set those to be separated as well. So that as you start hitting against your write service, the write service operations don't have to make any impact to the read operations, and reverse, the read operations don't have to make any negative impact to the write operations. Now, we showed this with DataAPIBuilder, putting this on a single endpoint right here so that we can separate it by connection strings or by configuration files that have unique connection strings in them. It's a neat way of just showing how CQRS can be implemented one step at a time. You can do small incremental steps, making it so that the service is somewhat separated like we did, or completely separated, pointing to a single database using its HTAP capabilities, or separating the database using its read-only replica capabilities. Now back inside the portal, one of the things I want to be able to show you is that if I go into the compute tab of my database, I can scroll down to the bottom and I can see just how many secondary replicas, specifically high availability secondary replicas I have, and I can make those changes. However, if what I want is a named replica, if I want only read-only and I don't care about the high availability, I can go down instead to data management and go into replicas here, and I can click create replica, and I can create up to 30 with a different compute configuration, meaning I can have serverless if I want, I can have them really large or really small, and that's how I could pick which type of replica I want. Remember, a named replica doesn't use application intent. A named replica actually has a unique name, and you use a connection string to go directly to that database. I wanted to show that to you because sometimes it could be a trick to figure out which replica you want and where they are in the portal. In Visual Studio, we still have DataAPIBuilder running in our terminal. I'm going to jump to that in the browser. Let me open that up. I've gone to the root, but let me go to /API/ info read only. Info read only now has an endpoint for REST that's automatically set up because of the alias that we gave it. But I want to show how we would do this inside Visual Studio in our application. So here we are in, remember I was reading the scalar value going directly to the database. I don't want to do that anymore. So let me just comment this out. And instead, I want to create an HTTP client so I can go against the endpoint directly. We'll start by just capturing the URL. So here's the URL we just went to, and I just need to change it to read write if I want to go to the other. Remember, DataAPIBuilder handles swapping out the connection string for me. First thing I want to do is create an HTTP client. This will be my headless browser that goes and gets my information for me. The next thing I'm going to need, though, is, let me go back and get this JSON that is returned so I can serialize this into a class. I'll say edit, paste special JSON. All right, so it knows that there's a root object. There was no name, so it just guessed. It knows that there is a value array. If we jump back to the JSON here, you can see there's an array named value here. It inferred then that the class must be called value. That's fine with a property called server info. Absolutely what I want right there. Okay, so I might make some changes, by the way, but this is great for a demo. So I'll say var read write. Is that the first one? Yeah, read write equals. Will await my HTTP client, and I will get from JSON async root element read write. Perfect. And then I will also get my read only, get the exact same thing from there. And those two objects I will write out. Let me write the read write first to read write dots. Value is my array. There better just be one, and then I can ask for server info. That should spit it out for me and tell me what it is. You can see that I need to do some null checking and stuff. This is read only. Great. And then just to make sure that it doesn't close on me, I'll say console.readline. Let me hit F5 and see what happens next. Oh boy, I left all the JSON here in the top line. Let me go ahead and delete that. Let me hit F5 again. It'll pop open my terminal and I can see read only and then read write. All right, so that's what I would have expected. I can see the read write and read only coming right here. I'm writing those out. And they're actually the opposite, aren't they? Let's see. I put the read-only URL in read-write and the read-write in read-only. Let's just fix that so that the demo works beautifully. hit F5 again. Now I could see read, write, and read only the way I would have expected it. All right, so that's important because now I can interact with my database without the need of a SQL client, without any of opening a connection. I can allow everything to be handled by my data API. And if you write your own data API, that's fine. If you use DataAPIBuilder, it's awfully easy. And so pretty simple, a handful of lines. I realize this is a demo, but it really is a straightforward way to interact with a database by going through a data API and by leveraging and using the CQRS pattern. And what is the CQRS pattern? The CQRS pattern is that segregation of responsibility. How did we do it? All right. Well, first, we looked at the database and separated it so there wasn't one database working as an HTAP database for both write and for read, but instead we separated it, having that primary write, but then introducing read-only replicas. And we even showed how to use high availability read-only replicas to make it so that our database is highly available. The next thing we did was we looked at our service, and we separated the read and write into two different endpoints and two different connection strings, making it so that we could call them independently, and they would individually call the correct database on the other side, making it so that the write operations and whatever compute is required in our service is isolated, and the read operations are also isolated as well. That made it so writing went right to one database. Meanwhile, reading went right to the other database. This is the CQRS pattern perfectly implemented. Now listen, CQRS is very straightforward. I think if I hadn't explained it to you, you would have eventually come up with it yourself. It's one of those things that's very powerful, but its simplicity is one of its biggest benefits. All right, using SQL, using .NET, and using DataAPIBuilder, we've implemented CQRS. Hopefully you can take this, translate it to your solutions, and make a difference in your next project. My name is Jerry Nixon. I'm on the SQL Server Developer Experiences team, and I look forward to seeing your next project succeed.